All right, so get ready because we're diving deep into the mysteries of the universe
That
today.
sounds exciting.
It is.
Yeah.
We're going to be uncovering mind-blowing facts about where it all began, and maybe even get a glimpse of where it's all headed.
Oh, wow.
Yeah. We're talking about cosmology, which is basically the study of the universe's origin, how it's evolved, and like
Oh,
its
it's
ultimate fate.
the really big questions.
Exactly. It's not just stars and planets we're talking about.
Right.
It's the big questions like, how did this whole thing even get started? And what are the fundamental forces that make it all tick?
It's a pretty wild ride that takes us from like the tiniest particles all the way to the biggest structures in the cosmos from the very beginning to now and even beyond.
And speaking of beginnings, we can't dive into cosmology without talking about the Big Bang, right?
Yeah, but the Big Bang is definitely going to be a key player in our deep dive today.
For sure. And the sources you've gathered not only explain what the Big Bang is, but they also lay out the evidence that makes this theory so compelling.
Yeah, and that's the thing about the Big Bang Theory. It's not just some random idea. It's backed up by some pretty solid observations and evidence.
So let's break it down a bit. Imagine if you can, in the entire universe, squeezed into a space smaller than an atom.
Smaller than an atom. Wow.
I know, right? And then, boom, this massive expansion thing start cooling down. And from that chaos, you get subatomic particles, then atoms, then stars, galaxies, the whole universe as we know it.
It's kind of hard to wrap your head around, isn't it?
It really is. So how do we know this crazy thing actually happened?
Well, one of the coolest pieces of evidence is something called the cosmic microwave background radiation.
Cosmic microwave background radiation.
It's like the afterglow of the Big Bang.
The afterglow.
Yeah, it's like a faint whisper, a little bit of leftover heat from that initial fiery moment that still fills the universe.
So it's like leftover heat from the universe's first and biggest oven.
You got it. And it's not just heat either. It's like a snapshot, a picture of the universe when it's super young, just 380,000 years after the Big Bang.
That's amazing.
Right. And this radiation gives us a ton of information about what the early universe was like and what it was made of.
And then there's redshift, which I found fascinating.
Oh, yeah. Redshift is a big word.
Basically shows us that all these distant galaxies are moving away from us, right?
That's right.
And the farther away they are, the faster they're moving.
Yeah, think of it like this. Imagine dots on a balloon. As you blow it up, all the dots move further apart, just like the galaxies in our expanding universe.
Okay, I'm picturing it.
And that's redshift. It's the stretching of light as objects move away from us. And it's one of the key pieces of evidence that supports the Big Bang Theory and the idea that the universe is still expanding.
So who came up with this whole Big Bang idea anyway? It's pretty wild to think someone just thought this up.
Well, the credit goes to Georges Lemaitre, a Belgian priest and physicist.
A priest and a physicist. That's an interesting combo.
Yeah, he imagined the universe starting from a single primordial atom, a point of unimaginable density, what we now call the singularity.
So a priest basically came up with one of the most important concepts in cosmology.
You could say that. Now, of course, his theory wasn't immediately accepted, but later observations, especially those made by Edwin Hubble, confirmed that the universe is indeed expanding, which gave Lemaitre's idea a lot more weight.
And you included some articles on Hubble in his work, and of course the telescope named after him.
The Hubble telescope has been absolutely revolutionary in our understanding of the universe since it launched back in 1990.
It's given us some incredible images.
Oh, yeah, it's captured stunning images of faraway galaxies, nebulae, star nurseries, and other celestial wonders.
It's amazing to think that this telescope is up there, orbiting our planet, constantly pushing the boundaries of our cosmic knowledge.
It really is, and thanks to instruments like Hubble and the tireless work of scientists and researchers, we're able to piece together this story of how the universe came to be and how it's changed over billions of years.
But I know there's still some big mysteries out there, especially those you are really interested in, like dark matter and dark energy.
Oh yeah, those are two of the biggest head-scratchers in cosmology.
What makes them so mysterious?
Well, take dark matter. We can observe the effects of gravity on visible matter stars, galaxies,
Right.
But there just isn't enough visible matter to account for all the gravity we see.
So there's something else out there.
Exactly. Something we can't see directly, but we know it's there exerting its gravitational influence, holding things together. We call it dark matter.
So it's like this invisible glue that binds the universe.
That's a pretty good way to put it. And then there's dark energy, which is even weirder. It's this unknown force that seems to be accelerating the expansion of the universe, pushing everything farther and farther apart at an ever-increasing rate.
So the universe isn't just expanding, it's expanding faster and faster.
Exactly. It's like our balloon analogy again, but this time, instead of just inflating steadily, the balloon starts inflating faster and faster.
That's wild.
Right. It's mind-boggling to think that these mysterious forces, dark matter and dark energy, are shaping the fate of the entire universe, even though we can't directly see or detect them.
Definitely mind-boggling.
It makes you realize how much we still don't know about the universe.
For sure. It's exciting and a little bit humbling at the same time.
Absolutely. And it's what keeps us exploring and asking questions.
And on that note, we're going to take a quick break, but when we come back, we'll delve even deeper into these mysteries and explore some alternative theories about the universe and its origins. So stay tuned.
Looking forward to it.
Yeah.
Yeah, it really is mind-boggling. And to make things even more complicated, we're still trying to figure out what dark energy is and how it actually works.
It's like we've got this incredible event, the Big Bang, that set the universe in motion, and we've got evidence like redshift and that cosmic background radiation to back it up, and now we're digging into these invisible forces like dark matter and dark energy.
Yeah, it's a bit of a cosmic detective story, isn't it?
It totally is,
Okay.
with twists and turns and unexpected discoveries and a whole bunch of unanswered questions.
Exactly.
Yeah.
And that's what makes cosmology so fascinating. It's all about exploring, discovering, and refining our understanding.
Now, you mentioned that your sources touched on some other theories besides the Big Bang. Were there any that stood out to you?
Yeah, there were a few interesting ones. One that caught my eye was the idea of a cyclic universe.
A cyclic universe. What's that?
It's like, imagine the Big Bang isn't a one-time thing, but part of a never-ending cycle of expansion and contraction.
Okay.
So the universe expands for billions and billions of years, and then eventually it collapses in on itself and then explodes outwards again in a new Big Bang.
So it's like a cosmic heartbeat.
Exactly. It's a pretty cool concept. And while it doesn't have as much observational support as the Big Bang theory, it's a good reminder that there are different ways to think about the universe and how it all began.
That's true. It's important to keep an open mind, especially when we're talking about something as complex as the universe.
Absolutely. Science is all about constantly questioning and refining our understanding.
Now, let's circle back to redshift for a minute. You said it's a key piece of evidence for the expanding universe. Can you walk us through how scientists actually use redshift to measure distances and track this expansion?
Sure. So when an object like a galaxy is moving away from us, the light waves it emits get stretched out, shifting towards the red end of the spectrum.
Okay.
It's similar to the Doppler effect, like when a siren passes by and the pitch changes.
Oh, yeah, I get it.
So redshift is kind of like a cosmic speedometer telling us how fast galaxies are moving away from us. The greater the redshift, the faster the galaxy is moving, and usually the farther away it is.
So by analyzing the light from these distant galaxies and measuring their redshift, astronomers can figure out how fast they're moving away from us and then estimate their distances.
That's it. And it's pretty amazing how much information we can get from just looking at the color of light.
It is, and this redshift data has helped us create those incredible maps of the universe, showing us where galaxies cluster and revealing the large-scale structure of the cosmos, right?
Exactly. And that brings us to another fascinating concept, the cosmic web.
The cosmic web.
Yeah, it's this mind-blowing network of filaments and clusters of galaxies, all interconnected by strands of dark matter and gas.
So it's not just random galaxies scattered throughout space.
Nope. It's this complex and interconnected structure that has evolved over billions of years, shaped by gravity.
And it's a reminder that everything is connected in the universe.
Precisely, even across vast distances.
Now, speaking of seeing these vast distances, you mentioned earlier how the Hubble telescope has captured these stunning images of distant galaxies.
Yeah.
Can you give us some specific examples of what Hubble has shown us and how it's changed our view of the universe?
Oh, absolutely. One of the most iconic Hubble images is the Hubble Deep Field, which showed us thousands of galaxies in a tiny patch of sky. It was a glimpse into the incredible vastness and crowded nature of the universe.
Yeah.
And Hubble has also given us these amazing views of nebulae star-forming regions and the remnants of supernova explosions. It's like having a front-row seat to the birth, life, and death of stars.
So we're basically seeing events that happened millions or even billions of years ago.
That's right. And Hubble doesn't just take pretty pictures, it also collects a ton of data on the composition, temperature, and movement of distant objects, giving us insights into how galaxies evolve, how the universe is expanding, and the mysteries of dark matter and dark energy.
It's really remarkable how these observations from Hubble and other telescopes have confirmed some of our theories, but also led to new discoveries and raised even more
It
questions.
really highlights the power of scientific inquiry and our drive to understand the universe.
Now, thinking about this expanding universe always makes my head spin a little.
Yeah, it's a big concept to grasp.
It is. But you mentioned that the universe isn't expanding into something, it's space itself that's expanding. Can you explain that a bit more?
Sure, it's a common misconception to think of the universe expanding like an explosion, with galaxies flying out into some pre-existing empty space.
Right, I can see how someone might think that.
But it's not like that. In the Big Bang model, space itself is created and expanded. So imagine a loaf of raisin bread dough rising in the oven.
Okay, I'm visualizing it.
The raisins, which represent galaxies, aren't moving through the dough, they're being carried along as the dough itself expands.
So the galaxies aren't moving through some empty void. The space between them is actually growing.
Exactly. And this expansion is happening everywhere in all directions. And that's why, from our perspective, most galaxies appear to be moving away from us. And as we discussed, the farther away a galaxy is, the faster it seems to be receding, which is what causes that redshift we talked about.
It's wild to think that space itself is dynamic, always stretching and changing.
It is. And it's not just expanding, it's doing so at an accelerating rate driven by that mysterious dark energy.
Okay, so we've talked about the Big Bang, the expanding universe, redshift, dark matter, dark energy. It's a lot to process, but I think it's important to take a step back and appreciate the enormity of what we're discussing.
I agree. It's
Yeah.
mind-blowing.
An expanding universe, billions of galaxies, these cosmic webs, invisible forces shaping everything. It's just incredible.
It really is. And it's this sense of awe and wonder that pushes us to explore further, to try and unlock the universe's secrets.
You've brought up so many fascinating points from your research, and I appreciate how you've woven in these alternative theories and perspectives. It's a good reminder that we're still learning, and there's so much we don't know yet.
Definitely. Cosmology is a constantly evolving field, and new discoveries are always changing our understanding.
Which leads to a big question that you wanted to discuss, the question of the universe's ultimate fate. What does all of this, the Big Bang, the expansion, dark matter, dark energy, tell us about where the universe is headed?
That's the million-dollar question, isn't it? And it's one that cosmologists are working hard to answer. There are a few possible scenarios depending on the nature of dark energy and the overall density of the universe.
Okay, so what are the options?
Well, one possibility is that the universe keeps expanding forever, eventually becoming cold and dark as stars burn out and galaxies drift farther and farther apart.
So like a cosmic fade out?
Yeah, kind of.
Yeah.
Another possibility is that the expansion slows down and eventually reverses, leading to a big crunch, where the universe collapses back in on itself, returning to a state of extreme density.
And maybe even triggering another Big Bang.
Exactly, like that cyclic universe idea we talked about. And then there's the possibility of a big rip, where the expansion accelerates so rapidly that it tears apart galaxies, stars, planets, even atoms themselves.
Okay, that one sounds a bit intense.
Yeah, it's a pretty dramatic scenario. But the good news is we're a long way off from any of these outcomes, so we have plenty of time to keep exploring and trying to unravel these mysteries.
That's reassuring.
And who knows, maybe along the way we'll discover some new physics, new forces, or new particles that will completely change our understanding of the universe and its fate.
That would be pretty amazing.
It would. Cosmology is full of surprises.
Well, this deep dive has been a wild ride. From the Big Bang's fiery start to this ever-expanding universe, we've explored the evidence, the mysteries, and the sheer scale of it all.
And we've just scratched the surface. There's so much more to learn and discover.
It's humbling to realize we're just a small part of this vast, constantly evolving universe. And yet, through science and our curiosity, we've been able to piece together this incredible story of its origins, evolution, and the forces that shape it.
It really shows the power of human ingenuity and our thirst for knowledge. And as we continue to explore the cosmos with new tools and technologies, I'm sure we'll uncover even more profound insights that will reshape our understanding of the universe and our place within it.
Absolutely. So to wrap things up, we've journeyed through the universe and explored some pretty mind-blowing concepts. But here's something to ponder as you continue your own cosmic exploration. If, as current evidence suggests, the universe is constantly expanding, what does that mean for the future of life and consciousness in the cosmos? What new possibilities might emerge as space stretches and time unfolds? Keep exploring, everyone, and never stop asking questions.
Yeah, it's incredible to think about all these forces and ideas we're still trying to wrap our heads around. It really shows how much more there is to discover out there.
It does. And, it's not just about understanding the universe on this grand scale. Cosmology actually connects to our understanding of physics, too.
Oh, right.
Yeah.
You mentioned that in your sources, the link between cosmology and particle physics.
Exactly. See, the early universe was basically like a giant particle accelerator. And by studying the leftovers from that early period, like that cosmic microwave background radiation, we can learn a lot about the fundamental building blocks of matter, the
Hmm.
forces that govern them. So we're looking back in time to when the universe was just a baby to see how the laws of physics were first established.
That's a great way to put it. And by understanding how those laws worked back then, we can get a better grasp of how they work now and what they might tell us about the future.
Now, before we wrap up this deep dive, I've got one more question that's been bugging me. We've talked a lot about the expanding universe,
Mm.
but if it's always expanding,
Hmm.
what does that mean for infinity? Is there an edge to the universe, or is it truly boundless?
That's a question that's been puzzling people for centuries. And honestly, we don't have a definitive answer yet.
Oh, really?
Yeah, the universe as we understand it right now might be infinite, or it might be finite but unbounded, kind of like the surface of a sphere.
I'm not sure I follow.
Imagine an ant crawling on a globe. It can keep walking forever without ever hitting an edge.
Ah, okay, I see. So it's possible that the universe has no boundaries, but is still finite in size.
Exactly. It's a bit of a mind-bending concept.
It really is. And it's one of those mysteries that makes cosmology so fascinating. It forces us to think beyond our normal ways of understanding things.
It challenges our intuition for sure.
Well, this deep dive has been an incredible journey. We've covered so much ground, from the Big Bang's fiery birth to the ongoing expansion of space. It's been amazing to explore the evidence, the mysteries, and the sheer scale of it all.
It's mind-blowing to think about, isn't it? We started with Georges Lemaitre's revolutionary ideas, then explored the compelling evidence from redshift and the cosmic microwave background radiation. And we even dove into those strange and powerful forces, dark matter and dark energy.
It's awe-inspiring to think that we're just a tiny part of this vast and ever-changing universe. And yet, through science and our own curiosity, we've managed to piece together this incredible story of its origins, how it's evolved, and the forces that will ultimately shape its fate.
It's a true testament to human ingenuity and our constant desire to learn and explore. And as we keep pushing the boundaries of knowledge with new telescopes and technologies, who knows what incredible discoveries await us. I'm sure we'll continue to uncover secrets of the universe that will completely transform our understanding of it all.
I have no doubt. So as we wrap up this deep dive into the universe, I'm going to leave you with a final thought to ponder. If, as the evidence suggests, the universe is constantly expanding, what does that mean for the future of life and consciousness in the cosmos? What amazing possibilities might emerge as space stretches and time unfolds? Keep exploring those mysteries and never stop questioning.